Hello everyone and welcome to today's interesting lesson. In today's math class, I'm going to show you how to solve simultaneous equations with three variables, in this case x, y, and z, using substitution method. A lot of students find it very challenging to solve simultaneous equations with three variables using this method, but trust me, I am going to make it very simple and straightforward for you to understand. Without further ado, let's get down to business. If you want to solve this kind of equations using substitution method, what you are going to do is to first identify the variable you want to make the subject of the formula, right? Remember, we are doing it using substitution method. So first thing to do is to find or to determine the variable that you are going to make the subject of the formula, so that it will be easier for you to solve for the other ones. Now, if you look at this, x is a variable, y is a variable, and negative z or z is a variable. What this means is that if you know the value of x, know the value of y, and know the value of your z, in the first equation, it will give you a 2. Here we have our equation 1. Here we have the second one, and this is the third one. That is what it means. So we are going to look for the value of x, y, and z in this very problem. How do we do that? Like I said, identify the variable that you're going to make the subject of the formula. So I'm going to write my solution. My advice to you or for you whenever you're doing this is to always choose the easiest variable to make the subject of the formula. What do I mean by that? If you look at this here, you find out that this z stands on its own. So it will be easier to transpose the 2x and the 4y across, and that becomes the value for z, than making y the subject. In this case, you have to divide by 4 in order to make y the subject of the formula. And if that happens, your right hand side will have fractions, which you might not want to work with, or which might be very cumbersome for you to work with. Let me show you what I mean. For example, let's say you choose to make z the subject of the formula in equation 3. What will you have? You now have z is equal to 5, the 5 on the right. Here you have a 2x, it's a plus, it's not going to be a minus 2x, that is if it crosses over to the other side. And here you have a 4y, a plus 4y, if it crosses over to the other side, it's not going to be a minus 4y. Therefore, your z is equal to everything here, right? It's very, very easy to work with this. If the z stands on its own, or if the y stands on its own, it's very easy to work with this. But if it has a number in front of it, like a number greater than 1, it becomes a problem for learners. But I'm going to use an equation, or I'm going to use a variable that the coefficient is greater than 1 to show you how to solve this, in case your teacher decides to trick you by giving you equations that do not have or do not stand on their own. For example, equations that do not contain a z that stands on its own or an x that stands on its own. Therefore, I'm going to use equation 1, and in equation 1, I'll make x the subject of the formula so that we can find the value of x and plug it into equation 2 and equation 3. How do we do that? I will say making x the subject, this is our subject in equation 1. Okay, so I'm going to copy equation 1 down. What do we have? 3x plus 2y minus z is equal to 2. I'm going to transfer everything here, okay, which is attached to the x across. And what shall we have? We now have 3x is equal to 2, the 2 here. This 2y goes across, it now becomes a minus 2y. The negative z also goes across, it now becomes a plus z. Now, what do we do next? To solve for x, we divide both sides by 3. The 3 on the left cancels out with this. We now have that x is equal to 2 minus 2y plus z over 3. This is the value for x or of x. The reason why I decided to make x the subject is because sometimes your teacher might trick you by giving you equations that will be difficult to find variables that stand on their own. For example, x or z, as you've seen in this very case. If you only know how to solve with variables that stand on their own, it will be very difficult for you to isolate variables that have numbers like 2 or 3 or 4 attached to them. Since x is now equal to this, what's the next thing that we're going to do? Next thing to do here is now to substitute the value of x in equation 2 and equation 3. That's the next thing to do. Let's say you made x the subject in equation 2. Okay, what you do is to now substitute the value of x in equation 1 and equation 3. Let's also assume you made x the subject in equation 3. You now substitute the value of x in equation 1 and equation 2, right? So if you remove x from here, you now have to put it in 2 or 3. So if you remove it from one of the equations, you have to substitute it in the other two. And that is just how to do it. Next up, let's do the substitution. So here we have an x, okay, and the value of x is 2 minus 2y plus z over 3. What do? I copy my equation down. Here I have x plus 3y plus 2z is equal to 3. So I'm going to substitute the value of x into this very equation. How do we do that? Remember, this is our x and our x is equal to this. I open my bracket and I will say 2 minus 2y plus z, okay, over 3. And I'll write everything here down, plus 3y. Remember, we only replaced x with its value. X is equal to this. So wherever we see x, we put this because x is equal to this. You copy down the 3y plus 2z is equal to 3. I'll now remove the brackets because the number in front of here is 1, so it's as good as multiplying it by itself or multiplying it by 1, so it's not changing anything. 1 times everything here is also everything here. Now what do? We say 2 over 3 minus 2y over 3 plus z over 3. You may be wondering, why did I now separate them? You see, this 3 is just a common denominator, okay? If I decide to add them, I'll get the original expression back. All I did was to separate them for clarity purposes. So here we have plus 3y plus 2z is equal to 3. Now, next up, how do we now remove the 3 underneath? To remove the 3 underneath, we multiply the entire expression or equation by 3. Why do we do that? If we multiply everything here by 3, the fractions or the denominators would be eliminated and we only have whole numbers. Remember that this 3 here only affects the numerators, okay? Not the denominators. It will only affect, you only multiply the 3 by everything at the numerator. Now let's do that. 3 times 2 will give us a 6 over 3 minus 3 times 2y will give you 6y over 3. Next up, 3 times z will give you plus 3z over 3. 3 times 3y will give you plus 9y. 3 times 2z will give you plus 6z. 3 times 3 will give you a 9. I'm going to bring it up here. Now, next up, let's now divide. 6 divided by 3 will give you a 2 minus 6y divided by 3 will give you a 2y plus 3z divided by 3 will give you a z. Here we have plus 9y And next up, we have plus 6z is equal to 9. All right, so let's clean this up by collecting like terms. I'll pick the y's first. Here we have a negative 2y. We have a plus 9y. Okay, let's now pick the z. We have a plus z here. We have a plus 6z here. Okay, and what do we have left? We now have our 2. What I will do right now is that I'll transfer, this 2 is just a constant, so I'll transfer it across. It's a positive 2 here. If I transfer it across, we now have a negative 2, right? This is a 2 here, and it's a plus. If I transfer it across, the equality sign now becomes a negative 2. Let's clean this up. Negative 2y plus 9y, just like saying negative 2 plus 9, it will give you a positive 7y. Okay, and the next one here we have a z plus 6z, just like saying 1 plus 6, it will give you plus 7z is equal to, here we have 9 minus 2. 9 minus 2 is equal to 7, and this is it. So we call this our equation 4. I need you to know and understand that whenever you are dealing with simultaneous equations with 3 variables, whether you're solving it using elimination or substitution, you end up creating 2 more equations, making it 5 in total. You have a 3 initially, plus the 2 more that you create either by elimination or substitution, and that will give you a 5 in total. Now we have the fourth one here. Okay, we have the fourth one here. The next thing that we're going to do right now is to look for the fifth equation. Remember that we substituted the value of x into equation 2. Now we're going to do another substitution into equation 3 right now. Now let me also write down the value of our x so that we don't forget. Remember that we made x the subject of the formula in equation 1. And what was our x? We said that our x, as far as I can remember, is equal to 2 minus 2y, okay, plus z over 3. This is the value of our x. And we also have it here. X is equal to 2 minus 2y plus z over 3. That's what we have here. So it's better to write it up here so that we do not forget. So this is our equation 4. Let's now look for equation 5. Let's look for equation 5. Permit me to write our equation 4 up here. So here we have 7y plus 7z is equal to 7. This is equation 4. Let me clean everything up to make life easier for us. All right. Remember, we substituted our value for x initially in equation 2. Now let's do for equation 3. Here we have a 2x, okay, plus 4y plus z is equal to 5. Let's now do our substitution. We have 2, open our bracket. Wherever we see x, we put everything here because x is equal to this. What do we have? 2 minus 2y plus z over 3. Okay, we have done our substitution. Now what is remaining? We now have a 4y remaining. 4y, or plus 4y rather, plus 4y plus z is equal to 5. Next up, let's simplify this expression. This 2 multiplies everything in the bracket. It only affects the numerator, not the denominator. 2 times 2 will give you a 4. 2 times negative 2y will give you negative 4y. 2 times z will give you plus 2z over, okay, I would say over 3. I'm going to split them afterwards so that you understand better. Plus, I bring everything down here, 4y plus z is equal to 5. Now, they have a common denominator, therefore let me split them up. Here we have 4 over 3 minus 4y over 3 plus 2z over 3. They have a common denominator and can be added back to have the original expression back. I'll copy everything here down. We have plus 4y plus z is equal to 5. Lastly, how do we remove the denominator to get a whole number here? We simply multiply by 3. For example, if the number as a denominator is 4, you have to multiply the entire equation by 4. If it is something like 3, 2, 1, if you have 3, 2, 1 here, or let's say you have 3, 2, 3, what you do is to find the lowest common multiple of 3, 2, and 3. And once you have your LCM, you multiply the entire equation or expression by that LCM, and it will help you clear the fraction and you get a whole number. That's the process. Now let's multiply out. 3 times 4 will give you a 12 over 3 minus 3 times negative 4y will give you negative 12y over 3. 3 times 2z will give you plus 6z over 3. And 3 times 4y will give you plus 12y. 3 times z will give you plus 3z. And then 3 times 5 will give you 15. Remember that the 3 which is outside multiplies everything in the brackets, not just the terms that have fractions. Now let's simplify this expression. 12 divided by 3 is a 4. Okay, 12 divided by 3 is a 4 minus 12y divided by 3 will give you a 4y. 6z divided by 3 will give you plus 2z. Here we have plus 12y plus 12y. And next up we have plus 3z plus 3z is equal to 15. All right. Now let's clean up. I'll pick the y's first, then I'll pick the z and the constant. Here we have negative 4y. Remember, we're collecting like terms. Like terms means that you add the y's and the y's together, the y and the y together, and the z and the z together. Y and z are not the same, so you cannot add them together. You can only add the y's together and the z's together separately. Here we have negative 4y plus 12y. And let me copy down the z. The first z we have here is 2z. 2z. The other one is plus 3z, right? This is the z. We have the constant, which is 4. I will say this is equal to 15. What do I do to this 4? I'll transfer it across the equality sign. It's a plus 4 here. If it crosses over, it now becomes a minus 4. Let's clean up. Negative 4y plus 12y, just like you say, negative 4 plus 12 will give you 8y plus 2z plus 3z is equal to 5z. This is equal to 15 minus 4 would give you 11. This is 11. 15 minus 4 is 11. You now see that we now have simultaneous equations with two variables. In this case, 8y and 5z. And here we have 7y and 5z. So we've reduced these equations from 3 to 2. And now they're going to be quite easier for us to work with. Here we call this our equation 5. Remember, I told us that you have to create 2 more equations or 2 extra equations to get up to 5. Now it's going to be very easy for us to solve. Okay, we shall also substitute again. We shall substitute again, and in this very case, we can choose either equation 4 or 5. Please, whenever you obtain your 4th and 5th equations, don't go back to substitute again. You are done with your substitution in the original equation, or I will say the mother equation. We made x the subject in equation 1, we substituted it in equation 2 and also did the same equation 3. Therefore, we are done with the mother or the original equation for now. We shall only start working with the fourth and the fifth equation. Why? Because we want to look for y and z. When we find y and z, we can now go and substitute the value of y and z into the original equation. We can choose either equation 1, 2, and 3, and that will help us to find the value of x. Okay? Once you have your y and z, just come and plug it in here. You can also choose to plug it in here. You get the same answer. It does not really matter the one you choose. Now, let's go ahead and substitute again. Now, I'm going to choose equation 4. I'm going to make y the subject in this case so that I will solve for z. Let me show you what I mean here. I will say making y the subject in equation 4. Okay, making y the subject in equation 4. Let's do that. Here we have 7y plus 7z is equal to 7. To make y the subject, I'll simply transpose the 7z across. Here we have 7y is equal to 7 minus 7z. Remember, this is a plus 7z. If it goes across the equality sign, it now becomes a negative 7z. To solve for y, I will divide both sides by 7. Here by 7. Let me do it separately. This is over 7. This is over 7. I'm going to divide everything on the right and everything on the left by 7 to solve for y. The 7 here cancels out with this. What are we left with? Y is now equal to 7 divided by 7 will give you a 1 minus negative 7 divided by 7 will give you a negative z. Now, it means that our y is equal to 1 minus z. Now, what do? We have made y the subject of the formula in equation 4. The next thing to do is to now substitute the value of y into equation 5 to solve for z. If you substitute y into equation 5, the y will go away and you'll be only left with your z. Okay? That's how it works. Let me show you what I mean here. Let me do the substitution. Here, I would say substituting, okay, y into equation 5. Okay, let's do that. Our equation 5 is 8y plus 5z is equal to 11. Let's now do the substitution. Wherever we see y, we substitute 1 minus z for it. Here we have an 8. The y here is attached to the 8. Remember, we know the value for y, which is 1 minus z. We put it in bracket because it's multiplying the 8. We now copy everything else down. Plus 5z is equals to 11. Okay, we can now multiply. Remember that the 8 multiplies everything. 8 times 1 will give you an 8. 8 times negative z is negative 8z. We have our plus 5 is equal to 11. How do we now solve for z? You've seen that the y is no longer there for now. So it now becomes an equation where z only exists. And with this, we can solve for our z. How do we do this? This is a 5z rather, not just a 5. First of all, transfer or transpose my constant. This is a constant. Any number that does not have a variable attached to it is just a constant. Therefore, I'll transpose or transfer my 8 across. And what do we have left? 8, okay, minus 8z plus 5z is equal to 11. This 8 here is a plus. If it goes over the equality sign, it now becomes a minus 8. Let's simplify further. Negative 8z plus 5 is just like you say negative 8 plus 5. It's going to give you negative 3z is equal to 11 minus 8 is a 3. How do we now solve for z? To solve for z, We divide both sides by -3. We divide the other one by -3. The -3 cancels out with this -3. Z is now equal to 3 divided by -3 will give you a -1. Therefore, our Z is equal to -1. We have the value of our Z. Now, let's go and solve for our Y. Remember, we're working on equation 4 and 5. Once we are done with these two equations where we find the value of Y and Z, we can now go and solve for the value of X in the original expression that we have, or the original equation that we have. Let me clean this up. I'm going to choose to solve for Z using equation 5. I would say solving for Z using equation 5. You can also solve for Z using equation 4. It doesn't really matter. Whether you use a 4 or a 5, you still get the same answer. But let me use equation 5 to solve for Z. What's our equation 5? We have 8y plus 5z is equal to 11. Let's now make do our substitution. We're solving for y. In this case, we have our z already. We have 8y plus 5. Remember that this 5 multiplies the value of z. And we know that our z is -1. It now becomes -1. We substitute the -1 for z. This is equal to 11. 8y is equal to, 5 multiplied by -1 will give you a -5. This is equal to 11. The -5 is a constant, so we can transpose it to the other side of the equation to solve for y. This would be 8y is equal to 11 plus 5. If the -5 goes over the equality sign, it now becomes a plus. And what do we get? 8y is equal to 11 plus 5 will give us a 16. To solve now for y, we simply divide both sides by 8. The 8 on the left cancels out with the other one at the denominator. Y is now equal to 16 divided by 8 is a 2. Therefore, y is equal to 2. Finally, let's solve for x. We know our y, we know our z. Z is equal to -1, y is equal to 2. We can now solve for x. How do we solve for x? It's pretty simple because we have found to remember, initially we were given 3 variables to solve for. They gave us an x and y and a -z, or a z rather. As the case might be here, it's now very easy. Since you found 2, you now have your y and your z. It's now easy to solve for x. You have 2 already. You can now solve for the one that you don't have. However, we can use the one we made the subject to find our x, because x is equal to everything here. You can just plug it here, or you can also plug it here in any of the 3 equations to find our x. However, let me use this one or that one over there. I will say solving for x. We said that x is equal to 2 minus 2y plus z over 3. With this equation, we can find our x. It doesn't matter whether you use this, or this. Anyone can go. X is equal to, we just substitute values. Wherever we see y, we put a 2. Wherever we see z, we put a -1. These are their respective values. 2 over 2. Remember that our y is 2. We put a 2 for y. Plus, what is our z? Our z is a -1. We put a -1 for z. This is all over 3. Let's simplify. X is equal to, we have our 2 here. -2 times 2 will give us a -4. Plus multiplied by a -1 will give us a -1. This is over 3. Let me simplify it further. X is equal to 2 minus 4, will give you a -2. And we have a negative 1 here left over 3. 2 minus 4 is a negative 2. And that's what we have here. We also have a negative 1 here left. Let me simplify. This is equal to negative 2, negative 1. If you punch it on your calculator, you get a negative 3 over 3. X is equal to negative 3 divided by 3 will give you a negative 1. Hence, x is equal to negative 1, y is equal to 2, and our z is equal to negative 1 as well, just as we found in the original or in the solution. Now, you can go ahead and confirm your solution. It's always very important that you confirm your solution by plugging in the values of x, y, and z into the equation to check for consistency, right? You need to check if your solution is correct. If it is correct or if you're right, then once you plug in your z, your y, and your x, it will give you the right hand side. This is the left part, right? Once you are able to solve and find the correct solutions and you plug them in here, you'll get whatever is on the right. Let me show you what I mean. For example, let's say we want to use equation 2 to test for consistency. What is our x? Our x is a negative 1, which means that whenever we see x, we put a negative 1 plus 3y. Whenever we see y, we put our 2. The next one is plus 2 and our z. What is our z? Our z is a negative 1 as we found or solved in the equation or in the problem. We found that z is our negative 1. Therefore, we replace the z with a negative 1. Here we have a negative 1 here. Let's see if we're going to get a 3 when we simplify. Here we have negative 1 plus 3 times 2 will give us a 6. 2 times negative 1. Okay. 2 times negative 1 will give us a negative 2. We want to see if it's equal to 3. Here we have negative 1 plus 6 will give us a 5 minus 2. 5 minus 2 is equal to 3. You've seen that when we plugged in the values of x, y, and z into equation 2, we got the other side. Okay, so it means that we are actually correct. All right, I believe you enjoyed this video and I hope it helped you in some way. If you have any comments, concerns, or questions, please let me know in the comment section and I'll be right there waiting for you. See you in the next video and bye.